What's up guys, it's Blake here. Welcome to my brand new YouTube channel where I'm going to talk about coding first, but then we'll see where that takes us. So my story is that I'm a software engineer with almost 10 years of commercial experience, and I went all the way from rural Poland to top uni in Warsaw without pretty much any resources or good mentors. And then I landed jobs at Samsung, at Google. Eventually I got my way into California and an AI startup there. And now I'm living this digital nomad lifestyle. Currently I'm recording this for you guys in Australia. I just wanted to escape the cold Polish winter. And I thought that it would be awesome to share what I know with you guys, and especially that the landscape is changing now and AI is making things so much easier, but it's still not taking programmers' jobs, believe me. I use it every day and it's very helpful, but it's not going to overtake this anytime soon. And also, like, if you hear people telling you that you can build stuff with like no code totally just by chatting in English with the AI, this is just not true. I mean, you can do a lot, but you still have to know how to guide the AI, and you have to have at least some basic understanding of what is going on and what the AI is writing. Because otherwise the AI duplicates a lot of stuff. It can create security bugs, and then one day, let's say, all of your customers' data leak to the internet, and then you have zero freaking idea what the code is doing. The AI just says, "Oh, sorry, yeah, like I made a mistake, but let me fix that." But then, like, who people are going to blame you or the AI, right? So you have to know what are you actually doing. But the good news is that it's easier than ever to get this basic knowledge with stuff like this guy over here. So recently I got my hands on this BBC microbit thingy. It costs like $20 US, and it's pretty powerful. It has like a 25 LED screen, 2 buttons or 3 buttons, a microphone, loudspeaker, accelerometer, magnetometer, and Bluetooth radio, stuff like that. Pretty powerful device for that price. And you can actually program this with a programming language that is based on visual drag and drop blocks. So it's very easy to visually understand how this all comes together, and we will do that in a second with a simple game that we are going to put on this device. And the best part is that this visual language directly maps to JavaScript or Python, whatever you want, which are like the top 2 hottest programming languages, I would say. So first you learn on these blocks, and then you can see how what you've done maps to the JavaScript code, and then you can be, oh yeah, now I get it. It's like, this is how it's all structured. And then once you learn basics of JavaScript or Python, then you can start to dive into the vibe coding tools, build some first micro websites and micro apps, and see how that all works, and then continue from there. So my idea for this channel, at least initially, is to take you through this whole process and help you just either get into tech or get better at programming, understand these things on a fundamental level. Because here's the kicker: I had to go through the 5-year uni, and I had to go the hard way, but now I think with what I learned, I can distill that for you guys into short lessons and actually teach you how to learn, because that's the whole thing. People ask me, like, what programming language do you use? And I'm like, yeah, now I program in C++, but it doesn't have any difference. It's today it can be C++, tomorrow it can be Python, then it can be Rust. The fundamentals are the same. And once you understand how it all works on a deep level, then you are a much better coder. So yeah, let's get into that. Today we are going to do a very simple game, it's already running on this microbit. So you see the dot moving left and right. And the game is that you have to press the button when the dot is exactly in the middle, and then you get a point. And if you press it in the wrong moment, then you basically lose. All right, so here we are in Microsoft Makecode, which is the tool to actually make that all happen. So let's create a new project over here, call it snap the dot, and this is where we start. It's pretty cool because right away we get this simulator of our microbit and two basic building blocks. Let's just focus on the first very simple one first. And yeah, let's maybe play around first just to see what's possible. The first thing people do often is hello world in all programming courses. I will maybe instead just show some funny icon. Well, it's not that funny, but it is an icon, so you see it shows it. And then we can actually toggle to JavaScript and see the actual code that makes that happen. And what else? We can actually write some more code. And you see that it automatically helps you with showing what's possible. So you don't have to remember all the syntax and stuff. You can just use whatever it's here. It helps a lot. It tells you all right, now you have to use icon names. So let's do icon names. Helps with that as well. And then dot is always the thing that you use to kind of go one level deeper. And now we can, let's do hard, why not? And then if we go back to blocks, we see that the blocks are here. So it's going back and forth very smoothly. So what the program is doing is showing first the smiley face and then the heart. And we can actually put this program on our microbit. We connect it over USB to the computer. Let's see, download. All right, now it works. So I can unplug it again and you see that it's showing, first showing the smiley face, then showing the heart. All right, so let's actually get into the real thing. So we get rid of the icons and start to do something more sophisticated a bit. So we have this LED panel that we can use to toggle any spot on the screen. So let's say we want to turn on x equals 2, y equals 2. So it's the middle dot. There we go. You can do whatever else, 0, 0. Everything in programming starts from 0. So pretty much never start from 1. You pretty much always start from 0 if you count anything. So this is 0, 0 point. So what do we want to do is actually have our dot in the middle row on the vertical axis, and then we want it to go left and right all the time. So how do we actually do it? Of course, we could just say, let's pause for 100 milliseconds and then let's unplot this guy over here. Actually, we can do it 1 second so you can actually see that it's going on. And then you can, why not, you can pause again and copy all of that and just build your funny little program this way. But I bet you don't like this approach, and I don't like that either. But you see that it's actually moving the dot for the first step. We can retry. You can see it appears, disappears, kind of works, but of course that's not what we are after. So let's actually get rid of all of that and start from scratch. So what we are going to do is we use a concept known as a loop. So we can pretty much
come back with our forever block that we had at the beginning. So this will just continue to run over and over again. So we need some way to track which dot are we going to turn on or off all the time. So how do we do that? Then we have the next concept that is very core to programming, which is variables. So you can think about variables as a box. So you can put anything you want there, like a number, a text, a logical value like true, false. It's also called Boolean value in the programming world. So we can make a variable that is called .x. You can come up with any name that you want. It doesn't matter. It can be in your language. It doesn't have to be English. So we create this box, and that box will just store for us where the little dot is at any given point in time. So we set it at the beginning to 0, and then what we can do is in each step of this big loop, we do the following. We first just to be sure, clear the screen, then plot wherever the X is now. So you see the shapes of it actually help you understand which blocks can fall into each places on the screen. So you see this rounded thingy here and here. So instead of the numbers, you can actually use the variables in these places. So you do it like that. So you will plot not always at point 0, but you will plot it at point pointed by the variable. And then the y will be constant, but it will be 2 because we want the middle row. So now, as you see, we just clear the screen and always plot it at the same point. Like nothing is changing this variable yet. So we may use the other instruction, which is change dot by 1. And then you see that actually it's very fast because it's just going without any pause. So you can add the pause block over here, and there you can actually maybe do 200 milliseconds, and then you see that it's actually, you want to plot it, change it, then pause, and then go over again. So there we are, we have our running thing, but what we want to do is we want to not for it to go away from the screen, because now it's actually continuing to run. If you go to the debug mode, you run the code and it's running, you can actually pause it and see that .x now is 20 because it's actually still going over this thing in the background. So now it's running from scratch, but after it reaches 5, it actually goes off the screen and then you can't see it anymore. All right. So what do we want to do? We want to actually make it turn around. And how do we do that? Let's think. So we are changing the .x by 1 always. So we go right. But if we want to go left, we would change it by -1, right? So let's say we start from 4 and then we change it by -1 each time. You see it goes left. So we want it sometimes to go by -1, sometimes by +1. So the way to do it is introducing another variable. So you can call it, for instance, step. And initially the step can be 1. And then we always change the dot not by a fixed value, but we change it by a step. So in this case, every single time it will change still by 1 now, so it's not very interesting yet. But here's the time to introduce another instruction, which is called a conditional instruction. It's present in pretty much all programming languages that are used nowadays. So what you can do is introduce some logic that is only executed if a given condition is true. So our condition here would be like a comparison condition. So we compare our variable. Oops. We compare it to 4, which is the last row. And then if it's 4, what we are going to do is we set our step to -1. So in this case, we will make it turn around, but then it's gone again. So we would probably introduce another if condition. So we want to first check if it's at the right edge and then reverse to the left. And if it's on the left edge, we reverse to the right. So now let's test it. It goes very nicely left and right, which is awesome. So yeah, let's see. Now the next pretty much final step is to add the input from the user. So tracking whether we should add 1 point to his score or we should just finish the game. So what we are going to do is we have to add one more input. You can say on button A pressed. And in this case, what we are going to do is we check where is our dot. So we can use the if-else conditional. So we have like 2 branches. So if our dot x, actually we want to introduce this comparison first. If our dot x is in the middle, so it's 2, then we want to increase the score, but we don't have the score yet. And guess what? The score will be 1 extra variable that again at the beginning we set it to 0, and then in this case we just change it by 1. And in the other case we have to somehow stop the game. How do we do that? Again, if the game is lost or not, it's part of the state of the program. And the state we store in variables. So we have a variable called game over, and we can initially set it to 0, or to make it more interesting, we can set it actually to false. So it can be very clear that it's going to only have like 2 values, true or false. And then in this case, if the button is pressed at the wrong moment, we set game over to true. Does it work? Let's see. It's moving, we click, count the score. If we click at the wrong time, nothing happens because we are not using the game over variable yet. So what we are going to do here is we just have to, here in the main loop, we don't want to move the dot forever. We actually want to move it only until game over is still false. So for that, we have other type of loop, which is called while. And as the word says, it continues to execute until this condition is true. So our condition would be while not game over. By the shape of these things, you can easily understand what item can fit where on the screen, right? So while not game over, you do all of that. And after game over is triggered, then what do? You just show, let's say, an icon that is the shock icon, and then you show a number, which can be our score. All right, that's right. So it's like, bam, doesn't work. It was in the middle, you saw it, right? It was in the middle. So actually it turns out that we have a bug in here that I introduced kind of by accident, but kind of no. So look at this point. So we are first plotting the dot, and then we are changing it by step. So in practice, if you think about it, we can go to the debug mode and see what happens. So it's like the game is running, you go, you plot the thing, change all the logic, you see everything, how it's going here. So you actually see that there is a trick, because now look, the dot is in the middle, you see it as in the middle, but in the state of the program, the dot is equal 3. So it's like 0, 1, 2, 3. So it's off by 1. So then if you press the button, you click and then .x is actually 3, but you see that it's in the middle. Why is that? So nothing just works automatically in here. You have to actually make sure that whatever you do makes sense, which is kind of obvious, but here I did a mistake by kind of not synchronizing my internal state with what I show on the screen. So what I should actually have done is I should first change the my internal state to some point, and only then actually show it on the screen. So the state that is shown is always the current state. So if I try it again, one more time, bam, 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 and now I lost 3 points. There we go. So yeah, now we have our program. It all works. So let's get it to our microbit again. So we connect it over here. All right, so now we can download our code over here once it's connected. And then, yeah, it's done. Let's see how it works. You can see that it's moving again. And I can try to press it right on time. Bam, bam. There we go. 4 points. Oh, 3 points only. There we go. We have done. So I think the last step would be for us to look into the JavaScript code and see how it actually looks. And we can maybe screenshot that so you can see how these guys map to our code. So the first part is the on button pressed. So you see that it's pretty intuitive. Like the instructions match whatever we have on the blocks. Then we have the initialization over here, which is setting up the variables. Sometimes it's repeated. This tool is not perfect. And then we have our forever loop. That is all the things over here. And yeah, there we have it. And there is actually so much more you can do with these microbits. For instance, you can convert it into a wearable. So you can count your steps or build your own whoop if you want to track your exercise and detect what exercise are you doing and count calories and stuff like that. And this is also very cool because you can build more serious game on a bigger screen with more buttons, kind of retro style. That is also pretty sick. And we are going to do all of that on this channel. So subscribe if that sounds interesting, and see you later.